Hello everyone and welcome back to Strength Classes. Today we are jumping into a super important topic, building materials, specifically rocks and stones. I've put together some of the most crucial MCQs that you're likely to see on your AE and JE exams. So think of this as a challenge, the civil engineer's gauntlet.
So the big question is, are you ready to take on the challenge? Let's find out just how sharp your knowledge is. I want you to treat this like a real test. Focus up, and let's see if we can get a perfect score together.
Okay, let's get right into it. Our first round is all about the absolute basics, the classification of rocks. We're going to cover geological, metamorphic, and chemical types. Here comes your first question. All right, question 1 is on your screen. Which of the following is an example of an igneous rock? Your options are A, phyllite, B, marble, C, aplite, or D, dolomite. Have a good look, lock in your answer.
And the correct answer is C, aplite. So, what's the deal with igneous rocks? Just think of them as the parent rocks, the originals, formed directly from cooling magma. Aplite is a fantastic example of a plutonic rock, meaning it cooled slowly, deep inside the earth. That's a key detail for your exams.
Excellent start. Now for question number 2. Marble is formed after the metamorphosis of which parent rock? Is it sandstone, granite, slate, or limestone? Now this one is a classic. You see it all the time in exams, so really think about it.
You got it. The answer is D, limestone. This is one of those questions you just have to know. It's a perfect example of metamorphosis. You take limestone, put it under immense heat and pressure, and it completely transforms, recrystallizing into the beautiful marble that we use in buildings. Now this table right here, this is pure gold for your exams. I'd seriously recommend grabbing a screenshot. These pairs are absolute must-knows. Just think, granite becomes gneiss, basalt turns into schist, sandstone changes to quartzite, and as we just saw, limestone becomes marble. Make sure you have these memorized. All right, let's switch gears a little to chemical classification for question 3. Identify the siliceous rock from the following options. Your choices are gneiss, marble, laterite, and dolomite. What's your gut feeling on this one? The correct answer is A, gneiss. So here's the trick. Whenever you see the word siliceous, I want you to think silica, which is basically sand. So siliceous rocks have silica as their main component, making them really hard and durable. On the flip side, rocks like marble and dolomite are calcareous, meaning their main ingredient is lime or calcium carbonate. Fantastic job on that first round. You're doing great. Now let's move into round 2, where we're going to test your knowledge on the physical properties and lab tests for these building stones. Okay, question 4 for you. The specific gravity of most building stones lies between, what do you think the range is? 3.2 to 3.5, 2.5 to 3.0, 4.5 to 5.4, or 1.2 to 2.2. This is one of those standard values you should definitely know. And the correct range is B, 2.5 to 3.0. But here's the really important part, the knowledge nugget. For most buildings, that range is fine. But what if you're building something huge, like a dam or a massive retaining wall? You're going to need a much heavier, denser stone, right? That's why for heavy engineering works, we specifically look for stones with a specific gravity greater than 2.7. Next up, a question from a topic that is almost guaranteed to show up on your exam, the Mohs scale of hardness. According to the Mohs scale of hardness, which mineral has the least hardness with a value of 1? Is it gypsum, sandstone, calcite, or talc? The answer is D, talc. Yep, it's the softest mineral on the scale, sitting at number 1. We're talking so soft you can literally scratch it with your fingernail. And on the complete opposite end of the scale, at number 10, you have the hardest substance, diamond. For most exams, if you can just remember 1 is talc and 10 is diamond, you're in a really good spot. Okay, now let's imagine we're heading into the lab. Question 6 is all about testing. Which test is performed to find out the presence of soluble matter in a sample of stone? Take a look at your options. Microscopic test, crystallization test, Smith's test, or impact test. The correct answer here is C, Smith's test. And I love this test because it's so simple and practical. You basically just take a few chips of the stone, put them in a glass of water, and give it a good stir. If the water turns cloudy, that's bad news. It means there's soluble stuff dissolving out of the stone and it won't be durable. If the water stays clear, you've got a good quality stone.
All right, I'm throwing a bit of a curveball at you with this next one, so pay close attention. Question 7. The acid test is usually carried out on which type of stone to check for lime content? Your options are granite, sandstone, basalt, or marble. Think it through.
The correct answer is B, sandstone. Now, this is where a lot of people get tripped up. The point of the acid test isn't to see if the rock is lime. The point is to see if the binding material holding the sand grains together is lime. If you put acid on marble, of course it's going to fizz. The whole rock is made of lime. With sandstone, we're checking if its glue is weak. That's a huge strategic point to remember for exams.
Okay, here we go, the final challenge. You have made it this far, you're doing an amazing job. This last round is all about the practical stuff, quarrying. How do we actually get these stones out of the ground?
Question number 8. A jumper is a tool used for which specific operation? Is it for dressing stones, polishing surfaces, making blast holes, or crushing aggregates?
The correct answer is C, making blast holes. A jumper is basically a big, heavy iron bar with a sharp chisel-like tip. Workers would lift this heavy thing up and slam it down over and over to slowly and manually bore a deep hole into solid rock. Once the hole was deep enough, that's where they'd pack the explosives for blasting. And this is it, the final question of the gauntlet. Let's finish strong. Which method is adopted for quarrying hard stones that have no fissures or cracks? Your choices are wedging, excavating, heating, or blasting.
The final answer is D, blasting. It just makes sense, doesn't it? If you have a huge, solid piece of hard rock with no natural cracks to take advantage of, blasting is the most efficient way to break it apart. You wouldn't want to use blasting on something expensive like marble, though, because you'd just shatter it. For those more valuable stones, you'd use a careful method like wedging to get clean splits and avoid waste.
And there you have it. Gauntlet complete. Congratulations, you made it through part 1 on rocks and stones. So how did you do? If some terms like Siliceous or Smith's test tripped you up, that's okay. It just shows you exactly which areas you need to go back and review. Remember, every concept is just another building block for your success. So what's next? To keep your preparation going strong, I highly recommend joining our Telegram channel for all the latest updates and PDFs. The link is right there in the description. And for the full experience, including complete test series and previous year questions, be sure to download our app, Strength Classes, from the Play Store. Thank you so much for joining me and taking on the gauntlet today. Always remember our motto. At Strength Classes, we're building knowledge one brick at a time. Keep studying hard, and I will see you in the next explainer.